topic for today is BOHR, Bohr's model of an atom. So we have to study this not as an independent model. Okay, so we can't study Bohr's model of an atom without knowing the history of it. So it's basically a continuation or improved version of Rutherford's nuclear atomic model, RNAM.
Hello?
So yes.
Hello?
Yes. सुन्दैछ बोलेको?
Continuation of हजुर.
Okay. So Bohr's model of an atom is the continuation or improved version of Rutherford's nuclear atomic model. So basically, Rutherford's model was the first one to explain the presence of a central particle that has maximum of the mass of the atom. So that is the nucleus. So Rutherford's model was the first one to name this as nucleus, right? And around the nucleus there are electrons that are revolving in orbits, right? So we have electrons that are revolving around orbits. So this was what Rutherford said, right? And there were so many flaws in this statement. So there were so many flaws, like why are the electrons not falling down? Because when electrons are revolving in an orbit, so they'll be constantly losing energy, right? They'll constantly lose energy because they're accelerating or moving at a constant velocity, whatever it. Even if they're moving at the same velocity, they will lose energy because they'll need some energy to maintain it, right? So भित्रको आफ्नो energy use गरेर they are maintaining their velocity. So why are they not falling down? So why are they not spiraling down and collapsing in the nucleus, right? So there were so many flaws of this Rutherford atomic model. So to answer all those flaws, a modified or improved version of Rutherford's atomic model was developed, and that was known as Bohr's model of an atom. So let's divide this into 4 segments. Okay, so let's say there are 4 postulates in Bohr's model. So first postulate is electrons revolve around the nucleus in stationary orbits. So this basically means these are special kinds of orbit where no energy is lost. So electrons can continuously revolve around at the same radius from the nucleus. So if one electron is, like, let's say this is the nucleus and this is the orbit of an electron, and this is at around, let's say, 2 micrometer. So 2 micrometer from the center of the nucleus, an electron is revolving around in this orbit, right? So according to this postulate, first postulate of Bohr's model of an atom, so this electron revolves in an orbit, and this orbit is known as a stationary orbit. And why is it stationary? Why is it called stationary? Because it does not cause the loss of loss of energy in the electron. So electron will not lose any energy, which basically means electron will sustain its path. So it'll keep on revolving in the same, it'll keep on revolving at this distance every time. Okay, it'll keep revolving in orbits, will remain stationary throughout. So it'll not lose energy and fall back down. Okay, so unless you supply some external energy, it may gain energy and go back up, right? But unless if that doesn't happen,
Unless you supply,
unless you कति केसहरुमा चाहिँ के हुन्छ भने when you supply energy to electrons नि, so electrons will gain some higher energy and they'll move upward, like in the higher orbit. So like for example, if you have an atom with 3 shells, okay, so there are 3 shells in an atom, so 1, 2, and let's say this is the 3rd shell, and there is a nucleus here, right? So an electron is revolving in the first orbit. Now यस्तो हुन्छ, so energy of the first orbit will be सबसे minimum, energy 1, let's say this is energy 2 and energy 3. So energy 1 will be least, energy 2 will be middle, and energy 3 will be the highest. So this energy will be the highest energy, and this will be the lowest energy, right? So when you supply energy to this electron has the tendency to gain this energy state and go to the 3rd orbit, okay, or 2nd orbit. So that can happen, but that is all external, right? So unless it is mentioned, this will not happen, right? So first postulate of Bohr's model of an atom was actually an answer to a drawback of Rutherford's model. So according to Rutherford's model, there was no explanation about stationary orbits, right? So basically, it was a flaw of a Rutherford model. किनभने if an electron was revolving around in a path like in an orbit around the nucleus, obviously the pull of the nucleus would overcome the centrifugal force. So the nucleus is positive, right, and electron is negative. So the pull on the electron will be
Oh,
so high, that the electron would start spiraling down. It will come spiraling down and ultimately collapse in the nucleus, right? So this was actually a drawback. The Rutherford model could not explain this, right? They could not explain the model could not explain this. So this was actually a modification of this part. So which basically means electron revolve around nucleus in stationary orbits. So these are the orbits that do not lose energy, right? They do not lose energy. They are stationary. They don't move up or down. Okay, up can
okay.
happen, but they'll not go down. They'll not spiral down to the nucleus. Okay. So Aditya, is this clear? Aditya?
Yes, yes.
Okay. Okay. Then we have the second postulate. The second postulate is electrons can gain or lose energy. Okay, so the electrons revolving in an orbit can gain or lose energy, right? And this has some criteria. You have to fulfill the criteria, only then you can say that this postulate is correct. So what is the criteria? I'll tell you about the criteria now. Now let us say that an electron is originally in the first orbit, right? First orbit of like outside the nucleus. So it is a part of the first orbit of outside the nucleus. Now in this atom I supply some energy from outside. Okay, so I supply some energy from outside and this electron gets energized. So electron gets enough energy to go to the third orbit. So electron starts revolving here, right? So this state is known as the excited state of an atom. Excited state of an atom. So in the excited state, one or more electron is absent from its parent orbit. So Afno orbit is the first orbit, right? The parent orbit of this electron is the orbit where it belonged, right? It belonged in the first orbit. But since there was some external factor, so here the external factor is I'm supplying some energy to it. So when I supply some energy to this electron is gaining the energy and it's moving two shells upwards and it's going to the third orbit, third shell, right? Which basically means it is leaving its parent orbit. So this state is known as the excited state of an atom. So you can note this down. So excited state of an atom is the state in which one or more electron leaves its parent orbit. So after parent orbit, it goes to some other orbit. So that is known as the excited state of an electron. Okay, excited state of an atom. Sorry,
Due to energy, right?
due to some external factors. So for this case, I'm telling energy. Okay, there can be some other external factors, but most of the time it will be energy only. Okay. So now this happens. Now what the thing is, anything in the excited state is not stable. So I have been telling you this since the first day of class, right? So everything in the universe demands stability, right? Even in our case, if we as humans, right, we can't stay excited for long. So if you are excited for a new phone that you just ordered, right, you'll remain excited till the order doesn't get delivered to you. Once the phone is in your hand, your excitement like gradually subsides, right? बिस्तारै घट्दै जान्छ excitement, right? And after like 10 days it becomes normal. Like you have a phone, it's normal now. It doesn't excite you anymore. But once you like opened Flipkart and just ordered the phone, till the day it arrived to your place, you were like excited, right? The state of excitement was still there. Like my new phone is coming, so you're excited now. So, but that excitement didn't last for long. It just stayed till your phone arrived to your place, like maybe for two more days after the phone came. But after 2 or 3 days, it becomes normal. It becomes part of your life, right? So now you just went back to your normal state, right? So same thing happens in an atom. So the electron cannot stay excited for long. So it will be very unstable for the atom itself, right? So the electron cannot remain in its non-parent orbit like this, right? So now what happens is the electron falls back to this orbit. So what needs to be done to fall back? Look, can anyone tell me what should be done so that this electron falls back here?
The electromagnetic wave missing about झर्छ
Yeah,
electromagnetic wave missing.
it'll release energy. Basically, it'll release energy, right? Basically, it'll release energy, and in some cases, this released energy is actually light or radiation. Okay, so this is basically basically a phenomenon of that happens in nuclear reactors and all those things. So electron gets excited, they fall back,
दा
they release. Yes, yes, bhai.
दा भनेपछि मेरोमा जति ठुलो एटम छ त्यति ठुलो चान्सेस छ मेरोमा खतरा वेभ हुनु
Exactly.
त्यसो भए
That's
मेरोमा
that. That's why we use uranium. Uranium is 235, right? Uranium 235. That's
भनेपछि
why.
अब
Yes.
आउटर मोस्ट लेयरदेखि इनर मोस्ट लेयरमा झर्दाखेरि यति बेसी एनर्जी अब
Exactly.
खतरा
Correct. Correct. What you said is if it falls from the outermost orbit to the innermost orbit, energy that will be released will be enormous, extremely high energy. Okay, and that energy sometimes it's visible light, sometimes it's radiation. Like for example, some metals when you like heat some metals, those metal give some color like strontium. So there's a metal called strontium. Its color is like sunset red one. So that color. So I think I'm correct in this, but I'm not sure. So there are metals that glow when heated. So this basically this thing is happening. So when you are heating the metal in the first place, the electron is getting excited, right? The electron is gaining energy and it's going like few orbits higher. But it cannot stay in that state because we know that everything in the universe demands stability. So we want stability at the end. So what happens is the electron will fall back. But for the electron to fall back, there has to be a condition that it has to lose energy, right? Because this, let's say this orbit can hold just 2 electron volts of energy. This can hold like 6 electron volt and this can hold like 8 electron volt. So an electron revolving in 8 electron volt orbit cannot just directly fall to a 2 electron volt. Okay, it has to lose energy. It has to lose 6 electron volt of energy to come back to this state, right? So now this liberated energy sometimes is liberated as visible light, sometimes is liberated as radiation. So basically this is the electromagnetic wave. It can be anything. It can be radio wave, it can be X-rays, it can be visible light, it can be gamma rays, right? So this is the excited state and non-excited state. How electron goes to the excited state. So you should know how does it go to the excited state. It goes to the excited state when it's supplied with some external parameters, let's say energy, right? It goes few orbits higher. Then after that it cannot stay in that state because it is unstable for the atom. So since nothing wants unstability, everything goes towards stability. It'll move towards stability, so it'll basically lose the energy in terms of radiation and it'll fall back to its original state. So does this like go in your head clearly or any doubt?
clear.
Clear? Okay, so basically how do we write this is, so there is a way to represent this. So let's say my innermost like parent energy of the orbit is E1. So this is E1 is the energy of the parent orbit, right? And E2 is energy of excited orbit. Okay, so E1 is the energy of the parent orbit, E2 is the energy of the excited orbit. The orbit that electron went after like gaining some energy, right? So now the electron has to fall to back to its parent orbit. So the amount of energy it has to lose is this much, right? So this is the final energy. So it has to lose E2 minus E1. So I said Ogigo example the final orbit had energy of 8 electron volt, initial orbit had a energy of 2 electron volt, right? So it has to lose, right, like 6 electron volts of energy, right? So this is basically what I said. I assigned numbers in the previous example. Now I'm assigning some alphabets to it, right? So now this is equal to h nu. So h is known as the Planck's constant, and nu is known as the frequency. So this h nu N-E-W nu. So it's a Greek letter. Okay, nu. So you have to just write it's the y lekha and just twist it.
Yeah.
So h nu. So this is the frequency. You can write it just v also like this. It's a v ulta parera v lekha huncha. So h nu. This is where nu is the frequency. So this h nu basically represents h nu भनेको चाहिँ energy of released radiation. So the energy that was released when the electron came back to its like parent orbit is denoted by h nu. Okay, and this denotes the energy of the released radiation. So what is the energy of the radiation that is released? So will that energy fall under the visible light category or X-ray category or let's say gamma ray category? So it depends, right? So by finding the value of this h nu, you can check whether the energy released will be of what spectrum, kun spectrum of fall गर्छ. So you guys know about the electromagnetic spectrum, right? So the spectrum starts with the lowest energy rays. Lowest energy rays, I mean the highest energy rays. Let's say gamma rays is the highest energy rays. Then we go to X rays. Then what do we have?
UV.
Yes, ultraviolet rays. Then we have visible. Then we have IR, infrared. Then we have microwaves, radio waves and microwaves. Radio waves and microwaves.
AM wave र AM wave र उयो हुन्छ नि
So AM त यहाँ हो,
FM
AM र FM.
दुईटा यसमा हुन्छ है
Yes, AM, FM. दुईटै यहाँ
होइन
हुन्छ.
माइक्रोवेभ कम्प्लिटली डेन्जरस हो रेडियो भन्दा
Microwave is not dangerous at all. So you have microwave ovens, right? So nothing happens to that when you put because when anything is exposed to radiation, right? A radiation is harmful only when it can ionize. So I have told you this like many times. Have I? So a radiation is harmful
मेरो
only.
क्वेसन हैन यसो अब माइक्रोवेभमा त खाना भएको तातिन्छ नि त हैन
It'll just heat up. Yes, exactly. So there are two possibilities when you are hit by radiation. It can ionize or either heat, right? So heating radiations are not dangerous at all. Like you stand in outside the sun, like sun will heat you in no time. Okay, so sun is so strong, like it's so far away, right? But still, if you just stand outside for 3 to 4 seconds, if you are like in a well lit area by sun, you just feel the heat, right? It just heats you. People won't come and tell you that you'll get sun cancer right away, like after 3 seconds exposure to sun. No, right? You won't get skin cancer, right? Because these are non-ionizing radiation. But yes, excessive if you are excessive exposed to sun, you might get cancer, but it doesn't happen like suddenly. It doesn't happen as like in the first time itself. But if you have a stream of gamma ray coming like this, and you stand here, okay, it's a gone case. It'll go inside and ionize. Game over. It'll go and ionize something. It'll mutate something. You'll start developing like red rashes all over your body, right? You'll start losing weight. You'll feel like you'll stop feeling anything. Okay, there is a video. If you don't get scared of don't like the explicit contents, right? I'll suggest you a video. The most radioactive person on the planet. So that was a Japanese guy. Okay, so he had a job in a nuclear reactor plant where he was supposed to mix something for nuclear reaction. I forgot the details. Okay, so he was there to mix it. So there were 3 people to do this, right? And one guy was like officer who stayed in the chair, and these 2 guys. So most radioactive person there's a story on YouTube. Okay, it's a true story. It's about 3 Japanese people. Okay, they had a job inside a nuclear reactor plant, and they were assigned some job. I forgot the job. These 2 guys were told to mix things. Okay, some dangerous things they were allowed to mix it, and this guy was the office guy who was not involved in doing all these things. So they were running out of time, and they had to mix something for to carry out the nuclear reactor. Yes, bhai.
इमेजहरु त तिनीहरु त बिल्लै छ त
के चाहिँ
भइसक्यो तिनीहरु त मेल्ट
What?
भइसक्यो त इमेजहरु त
I didn't understand.
सुन्नुहुँदैछ
सुन्दैछु के मेल्ट भयो what melted?
मान्छेहरु मेल्ट भइछ त
Exactly, the most radioactive. It's there on YouTube. If you just search it, the most radioactive man on earth. Right? So it's a story about this Japanese guy. So there is a real picture of this guy in the hospital, like just before his death. It's very horrifying. Okay, don't see that. You'll not sleep for 2 days. Don't see that. It's like just bones hanging. Okay, it's like. But like if you're interested and if you don't get afraid of all these things, just watch it. It's very interesting. So radiations are only harmful when they are ionizing. So when they can mutate, go inside and mutate and do any adverse effect to the cells, right? Cell co structure, cell co functioning, if they can affect some way or the other, then that kind of radiations are harmful radiations. They are ionizing radiations. These 2 are the most ionizing radiations. Gamma and X-ray. Okay, X-ray, weaker X-rays are used for medicinal uses, right? Medicinal uses and such. Or high energy X-rays are very, very dangerous. They can ionize completely. Your body can be completely ionized, right? There may be mutation. If there are some unfavorable mutations, and eventually they'll prevent cells to divide. Okay, so basically, if you have like, if you are exposed to radiation at this moment of time, right, your cells will not divide. Your cell, and the ray is like supposed to be ionizing. If it's gamma ray, your cell will stop dividing. Your cells will totally stop dividing. You'll die with the same cells that you have right now. So you'll not live for long as well. You may, like, at most medical attention lane, you might live more like around a month, right? You won't live after that. Your cells won't divide at all. They'll like totally not divide. So that is the harmful effect of EM waves. So all of these things are electromagnetic waves, right? EM waves. EM waves. So these are all EM waves, and so this part of the spectrum is very harmful. Other than this, these are not that harmful, right? So this is the thing that I wanted to tell you. So is this clear?
Clear.
So why did I come to this point? So this point arrived because of this h nu. So this h nu is the energy of the liberated, the radiation that was released, right? So this is the energy of the released radiation. Radiation released. So by knowing the value of h nu, you can tell which radiation it is, right? By knowing the value of h nu, you can tell which one is it. Is it gamma? Is it X-ray? Is it ultraviolet? Or is it, like, at the end, microwave? Okay. So by knowing value of h nu, you can find this. So h is a constant; it will remain constant every time. So for any value, h is always a constant. It's called Planck's constant. And frequency. So frequency will change as well, right? So highest energy, lowest energy. So this will have the lowest frequency. This will have the highest frequency, right? So something like that. So by comparing the value of, basically we are comparing the value of frequency. We are not considering the Planck's constant at all. This has no use right now. So we're just comparing the value of frequency and telling which radiation is getting released. Okay. So is this part clear?
Clear.
So there are two things that we did right now. So Bohr's model of an atom. Electrons revolve around the nucleus. So electrons revolve around the nucleus in stationary orbits. So the stationary orbit is ekdam very important. Okay. And electrons gain or lose energy. They lose energy when they go up or down. Okay. So when they gain energy, they go up. When they lose energy, they come down. Okay. So that is a possibility in electron movement inside atom. So we did this. This is done. Then what did we do next? Then we discussed about what will be the energy that is released. That is E1, E2. Then we found that h nu is the energy that is released. Energy that is released after. Yes, bhai.
त्यसमा 6 इलेक्ट्रोन भोल्ट हैन
6 electron volt. Yes, correct. Okay.
सपोज 6 इलेक्ट्रोन भोल्ट मेरो एनर्जी निक्ल्यो
Yes.
इक्वल्स टु के भन्थ्यो
h nu equal to 6 ev. 6 ev equal to h nu.
तर मैले त उयो म्यु खोजेको नि त म्युको भ्यालु खोजेको नि त
Yes, you want nu.
frequency हो नि त
Yeah, you want h nu. H nu equal to 6 ev. Now,
मैले चाहिँ म्युको भ्यालु फ्रिक्वेन्सीको भ्यालु खोज्नु
yes, 6 electron volt, like, convert into joules divided by Planck's constant value. So you'll get the frequency in meters. Not
The
meter,
frequency,
was 1 by second. Second inverse also you'll get the frequency. Okay. So you just need to put the value of.
जति बेसी फ्रिक्वेन्सी त्यति रिएक्टिभ भन्दिम न
Yes, exactly. जति हैन जति बेसी frequency what? Yeah, okay, that can be inferred. Okay, correct. Yes. Fine. So this is clear. So let's try to understand one more concept. So do you guys know about centrifugal force? So centrifugal, there is the forces in a circular motion. So whenever something is in a circular motion, so let's say
Hello.
yes, bhai.
Hello.
Yes, bhai. Can you hear me?
हजुर हैन त्यो
So-
बत्ती झ्याप्पै गयो कि वाइफाई नै
Do you know what this is called? This मेलाहरूमा हुन्छ नि मेलाहरूमा ठुलो घुम्ने हुन्छ नि हो यु स्टे इनसाइड दैट थिङ एन्ड यु जस्ट ठुलो हुन्छ नि
मेरी
घुम्ने
गो राउन्ड
मेरी गो राउन्ड त कमन नेम हो इट्स कल्ड फेरिस व्हील
ए घुमेको घुमेकै होइन
Ah, yes, Ferris wheel. This was discovered by a guy in the US called something Ferris. I don't know his name. So Ferris was the name of the person. So this is a Ferris wheel, okay? And this thing lies in the center of the wheel, right? And the wheel just rotates like this. Why is the wheel not going forward or backwards? So this is because there are two forces that act simultaneously. So one force that keeps the Ferris wheel inside, makes the Ferris wheel directed towards inside. That makes it revolve, like rotate around the axis. So this force is making it rotate around the axis. Now there is another force that will act against this force, right? Which will try to prevent the Ferris wheel to go out. So it'll cause the Ferris wheel to go out like this. Okay. So this inward force is known as the centripetal force, and the outward force is known as centrifugal force. So centrifugal force is the force that goes against the centripetal force. So centripetal force is directed towards the center. Centrifugal force is directed away from the center. So like if I give you an example, so there is a thread like this, and you tie a rock at the end of it, right? And you're revolving the rock like this with the string. Now suddenly, if the string snatches, will the rock keep moving this way? No, right? It'll go in one direction. So suppose I'm revolving like this, and at this moment of time, this thing snaps into half, right? So this rock will keep moving in this direction only, right? So this is the action of centrifugal force. Now, as soon as the rope breaks up, there will be no centripetal force. There will be no force keeping the rock inside, right? So now only centrifugal force will be present, which will throw the rock outside. That is the reason why when the rope snatches, the rock will not continue the circular motion. So is this centripetal and centrifugal force going in your head? So centripetal force is the force that goes inside, right? It'll always favor the circular motion. So centripetal force is the one that favors circular motion, right? And centrifugal force is the one that always opposes that motion. And these forces are equal and opposite. They are always equal and opposite in a circular motion. That's why we don't see the wheel going forward or backward. It just goes around and round in the same axis, right? Now, as soon as the centrifugal force is weak, as soon as the centrifugal force becomes a little weak, the centrifugal force will overpower it, and the centrifugal force will push the thing outside. So if by chance this axis breaks, right? There is sudden disconnection between the axis and the wheel will go in this direction, right? Because the wheel is moving in this direction. So if the wheel is moving in this direction and the axis snaps up, so it'll go in this direction, continue, right? It'll continue in the same path. Okay? So that should be in your head. So what is centripetal force and centrifugal force? So centripetal force is the force that favors the circular motion. It goes inside. It's directed towards the axis of the circular object, whatever it is. It's directed towards the axis. And centrifugal force is the force that is against the axis. That'll prevent the circular motion. That'll go against in the direction opposite to the axis, right? So that should be clear. So okay, so I'll abruptly come to a formula. So there is a thing called centrifugal force formula. I'll abruptly come to it. I'll not derive it. I'll do that in mechanics later. So centrifugal force is defined as mv square upon r. So mass of the thing that is rotating, v square is the velocity of the velocity at which it's rotating, that goes squared, and this r is the radius. Okay. So now let's apply this to the atomic level. Let's apply this to the atomic level.
Centrifugal.
Yeah, the centrifugal force, right? Centripetal and centrifugal is same. They are all opposite and equal. So this is centripetal as well. So no problem. You can call this centrifugal as well. Okay. So they are equal and opposite. So you can have anything. mv square by r is centrifugal as well, centripetal as well. Okay. Clear? Okay. So let us assume that electron is moving here. Okay. Now this electron is, according to Bohr's theory, this electron stays in that orbit, right? Which basically means the pull that the proton provides to the electron is balanced by the centrifugal force produced by the velocity of the electron. Correct? So the first force is the centripetal force that pulls it inward. So that is basically the electrostatic force of attraction between the protons in the nucleus, or protons, specifically one proton in the nucleus, to the electron. So the proton is pulling the electron in. So that is the centripetal force, right? So it is pulling in.
हजुर हजुर
Now, since the electron is not going in or it's not going out unless some energy is supplied, so in the basic or the normal state, unexcited state, it's not going anywhere. The electron is not going anywhere, it's continuing its rotation, which basically means there is a force that is equal and opposite to the force that is exerted by the proton on the electron. So that is the centrifugal force, right? So now centrifugal force is this one, m v square upon r. Now what is the centripetal force? Centripetal force is the electrostatic force of attraction. Electrostatic force of attraction. So what is force को formula? Electrostatic force को formula 1 by 4 pi epsilon naught q1 q2 by r square.
Force.
So is this statement clear? Sitesh?
Same da.
Clear?
Other da. Clear.
Okay, nice. So यति clear भयो नि त भयो नि. So we are almost at the end of the thing. So this is purely conceptual. Okay, you can't come to this conclusion without knowing the concept. So you can just by heart it. Yes, bhai.
दासको फर्मुला के छ भन्दा mv स्क्वायर बाइ r भनेको छ नि त हैन
Yes.
r देखि इन्भर्सली प्रोपोर्सनल मास र भेलोसिटी स्क्वायर सँग चाहिँ प्रोपोर्सनल
Proportional. Yes.
भनेपछि इन केस अब मेरो फर्स्ट अर्बिटमा थियो इनमोस्ट अर्बिटमा
Okay.
त्यही बेला ब्यालेन्स गर्नुको लागि त्यो फोर्स हुन्छ नि सेन्ट्रिपिटल सेन्ट्रिफ्युगल
Yes.
भेलोसिटी सन्दा बेसी हुन्छ त्यो
Exactly. किनभने the pull will be the maximum ni त, right? So since it is closest to the nucleus, proton will pull it maximum, right? It will pull the electron maximum. So it has to have like counter force should be higher as well. So obviously it can't increase its mass. Yeah, mass त increase हुन सक्दैन, mass is always constant, right? So mass cannot increase. Distance पनि constant छ, right? So you have to only increase the velocity, right? So velocity is the only factor that will change, because according to Bohr's theory, this distance is also not changing. Mass त change हुँदै हुँदैन. So electron will have a fixed mass, right? So only thing that will change is velocity. So the things that are revolving inside, like it's similar to the solar system. Mercury ko one entire year is almost few days for Earth. Okay, so Mercury revolves faster than Venus and Earth, right? Because it's closest to the sun. What? के गर्नु पर्यो? Yeah, it obviously, else Mercury will go inside the sun ultimately. So it'll start spiraling in and go in. Like if the centrifugal force is not equal than the centripetal force, Mercury will spiral and go inside the sun one day. So that is not happening, right? Mercury is revolving in its own orbit. So it should have a velocity that will counteract the centripetal force. Now since Mercury is located close to the sun, right? So Mercury is located close to the sun. So as distance decreases, gravity will increase, right? So the thing that is more closer will attract more. Okay? So gravity depends on distance. Gravity depends on distance of separation. So if the things are close by, the gravity will also be maximum. If the distance is far away, the gravity also will decrease. So now to maintain this gravity pull that will cause the Mercury to fall down, it will have to revolve in a velocity higher than any other planet. So the revolution speed of Mercury will be higher than any other planet. So Mercury completes one entire revolution around the sun in few days. Okay? So you can like analogy गर्न सक्छ त्यस्तो. You can compare it with things like that. So is that clear? Is this clear, this thing?
So
Nice. So now what we do is, now let's get the final derivation out of it. 1 by 4 pi epsilon naught. So what is Q1? Q1 is an electron. Q2 is also an electron. It's a proton. So proton को E नै लेख्छ हामी r square. So you cut this out. So what do we need? We need formula for E.
तर माइनस लेख्नु परेन
You can write minus. That'll just define the force only. It'll just define the direction of the force, right? You don't need to make negative. So just negative will symbolize that the thing is attractive, right? Because proton and electrons are एउटा positive एउटा negative. So this sign will indicate the force is attractive force.
the E चाहिँ के हो?
कुन चाहिँ भाइ? This E is electron. So charge भन्दैछ नि त, charge 1, charge 2, right? So we consider, yes भाइ.
1 by 4 pi epsilon naught को भ्यालु त 1 हुन्छ हैन त्यो बेला
It can be, cannot be also. For if the यस्तो हुन्छ नि, permittivity of free space अब के हुन्छ value. So it depends on where it is, where the atom is.
अब त्यो त भएन किनभने अब प्रोटोन र इलेक्ट्रोनको बिचमा त केही छैन नि त अब त्यो इनरमोस्ट
There is space, exactly. But this will not be one neither. And this will not be 1 किनभने permittivity of free space को value छ नि त, we have some value of permittivity of free space. I think it's 8.85 into 10 to the power minus something, right? So this is the permittivity of free space only, so it will not be 0, it will not be 0. So where was I?
होइन भ्याक्युमले सबभन्दा बेसी पर्मिट गर्छ होइन
भ्याक्युमले सबसे बेसी permit गर्छ, yeah, okay, yes, but it is not, it is not absolute neither, so you can't define the permittivity of vacuum to be 1 neither, so it is not something absolute. So that is like हामी सबै कुरा रिलेटिभमै हेर्छ नि त, right? So we just keep the permittivity of free space to be some value, so we don't put it like 1, so it is without any destruction, without any obstruction, so we can't say that permittivity of vacuum is 1. Okay,
त्यही कुन सिचुएसनमा चाहिँ अब फुल्ली पर्मिट हुन्छ
त्यो चाहिँ अब डिपेन्ड गर्छ, सो इट विल डिपेन्ड टोटली नि, अब वेभ्समा पनि डिपेन्ड गर्छ नि त्यो चाहिँ, जस्तै सो जस्ट रिमेम्बर इट टिल हियर, ओके वेट, ओके आई विल कम्प्लिट दिस यो डेरिभेसन एन्ड आई विल एक्सप्लेन द्याट ल. mv स्क्वायर डिभाइडेड बाई आर इक्वल टु 1/4πε0 इन्टु ई, दिस इज प्रोटोन एन्ड माइनस ई द्याट इज इलेक्ट्रोन डिभाइडेड बाई आर स्क्वायर. सो mv स्क्वायर divided by r equal to negative of 1/4πε0 g square divided by r square. So this is the final.